Okay, we're going to go over some of the remaining problems like I promised you guys for differential equations. And then hopefully this is very helpful for you. And just getting things squared away over here on my end. So let me see what we want to do, right? We're going to try to do questions 4, 5, and 6. And then the remaining questions 12, 13, and some of these others. So I actually imported a version that gives us space because I don't like going back and forth and scrolling. So this is what we're going to try to do 4, 5, and 6 again, okay? So we're going to go over these here in a nice Thanksgiving. Like I said, it's important for you guys to work on these, even if it is a break. So first derivative here. Okay. What we know, again, is this is really the definition of finding an antiderivative subject to some condition. And that condition is going to be f of 0 is 1 now. So this means if we go through the details again, having a differential equation, 3x2 to the third power. I'm going to move my microphone. All right. Now, again, what this means for us, this is the definition really of an antiderivative, but it's hidden as a differential equation or described also as a differential equation. I'm enjoying my coffee on this Thanksgiving morning, giving thanks for the ability to show you guys how to do these things. Now, we're going to have to integrate. This is a indefinite integral. We're going to use u substitution on this. So here's our u. And of course, we need du dx. So we're going to differentiate with respect to x. And this derivative is actually 3. So du dx is 3 over 1. And we got to solve for dx here. So we get what? Du 3 dx, divide both sides by 3. And I get a dx is du over 3. U to the third, du over 3, pull out that constant. One third u cubed du. Okay. So using our power rule, we end up with 1/12 u to the fourth plus c. We're going to need more. Out of page. But we want to go back and remember what u was. So it's 3x plus 2. So, okay. There we go. This is the function. Okay, we did our integration. Now, this condition we have to apply is f of 0 is 1. We got to solve for c again. So, okay, f of 0 is 1. Plug in 0 wherever there's an x, and that value is actually 1. So 1 is 1/12. 3 times 0 plus 2 to the fourth plus c. And that looks like we have 1 is 1/12 times 2 to the 4th plus c, or c will be 1 minus 2 to the 4th over 12. Replace 1 with 12 over 12. So 12 minus 2 to the 4th, both over 12. And I know it's pretty early here to let's figure out what 2 to the 4th is, right? 16, I guess. Hopefully we're okay. So negative 4 over 12. C is negative 1/3. So hopefully we get negative 1/3 for C. So final answer. 1/12. 3x plus 2 to the 4th minus 1/3. So there you go, ladies and gentlemen. There's the antiderivative function. And all right, that's one down. Okay, let's go to number 5. And again, it's the first derivative here. So, I mean, I'm not going to go over the detail there like I did prior. I'm just going to remind you that if I want to find the function, I have to integrate 6 secant 3x tangent 3x dx. And again, it's subject to a condition known as an initial condition. And we're going to find out what this is now. Okay. So again, we're going to have to integrate using u sub, where u here is 3x. So we have u substitution here, here. If that's the case, du dx is 3. Cross multiplying, if we create a proportion again, we'll find du dx will be, well, dx will be du over 3. So we're going to replace everything and substitute everything here. This is our u. Replace dx with du over 3. Now we get the integral of 6 secant u tangent u du over 3, where 6 divided by 3 will give you a 2. So we pull out the 2. Let me move something here. And we integrate. This is by u sub. So this will be 2 secant u. And this would be plus c. But we know u would be 3x again. So here is what we have to go back and do, resubstitute. Now, the condition here is f of pi over 12 is negative 4. So pi over 12 is negative 4. So I'm going to plug in for my x, pi over 12, because this is what this function is equal to, and the x value, same x, pi over 12. But this answer is negative 4 when x is pi over 12. So we have negative 4 is 2 secant 3 pi over 12 plus c, which is negative 4 equals 2 secant, looks like pi over 4 now, plus c. We're going to have to get some extra page. Okay. Now, question's going to be, what is secant 45 degrees? Now, I want you guys to note something. If I can find a color, maybe we'll keep it blue. Let's note that cosine pi over 4 is 1 over the square root of 2. So secant is the reciprocal of that, so that's just the square root of 2. Say, okay, square root of 2. So negative 4 is 2 square root of 2 plus c, which means c will be, if I subtract, oops. Yeah, let me double check. Are we okay? Okay. Still enjoying my coffee. Just woke up, so we got to be careful. Here's our constant c, right? Negative 4 minus 2 square root of 2. So the function is, the answer is 2 secant 3x minus 4 minus 2 square root of 2, looks like. All right. Just waking up with some differential equations. Not too shabby. All right, waking up with differential equations. Good. Let's look at number 6. It looks like, again, another U sub question. Wow. Meaning the variable here is now theta. Okay, they can change that variable to any letter they want. So we'll say f of theta now is the antiderivative of 6 cosine 3 pi minus 1/2 theta. This will be d theta now. And here's our condition here. F of 3 pi is 8. So I'm saying that the integral here is another u sub. Here's our u again. It's another u sub integral, where u is 3 pi minus 1/2 theta. Du d theta is negative 1/2. So we need d theta. So if I cross multiply, I'm going to bring the negative 2 with me. Negative 2 du is d theta. Let's double check. Yeah. So it looks like we're there. So d theta, this will be negative 2 du. Okay. F of theta. Integral of 6 cosine u times a negative 2 du. Right? So I'm just going to integrate this. Okay, so we get negative 12 cosine u du. Now we need the antiderivative of cosine. And that's just sine. Negative 12 sine u plus c, where u is, remember what we said in the first place. So, okay. There's our u. So f of theta. And u is 3 pi minus 1/2 theta plus c. All right, what's the condition? F of 3 pi is 8. So we're going to plug that in for theta. So we're going to plug in 3 pi. F of 3 pi is 8. So 3 pi here, 3 pi here. We say it's 8. 8 is negative 12 sine 3 pi minus 1/2 3 pi plus c. Okay. It's get some extra paper. Add a page. Let's do some arithmetic over here. Okay. So we have 3 pi. Let me get out my purple. And every time we do algebra or arithmetic. 3 pi minus, all right, 3 pi over 2. Multiply this by 2, 2. So we'll get 6 pi over 2 minus 3 pi over 2, which is simply going to be 3 pi over 2 now. So 8 minus 12 sine of 3 pi over 2 plus our constant c now. Sine of 3 pi over 2 now. Let's see, what is sine of 3 pi over 2 going to be? Now I'm not awake. I can do derivatives in my sleep. Not awake. Oh, what is this? This is pi. This is 2 pi. 1 pi over 2. Oh, here's our 3 pi over 2, and that's negative 1. Alrighty, so not even awake. 8. See, then this is equal. Told you. 8 equals negative 12 times negative 1 plus c. So 8 will be 12 plus c. C will be 8 minus 12. And then c is negative 4. So negative 4. That c here is really negative 4. If I can find even the right tool. Negative 4. Okay. F of theta equals negative 12 sine 3 pi minus 1/2 theta, and this will be minus 4. Alrighty. Now, I believe we did 7 and 8 in class. These are second derivatives. So we're going to start with 9 here, ladies and gentlemen. And this is a second derivative now. Okay, and we have 2 conditions. So, second order differential equation. Second order. So this is going to be, let's do the details like we did before. The variable now is t. Okay, so d dt of f prime t is equal to t to the minus 3/2 power. That means that f prime t is the antiderivative or the integral of t to the minus 3/2. There's dt. So we're going to integrate t minus 3/2 plus 1/2 over a negative 3/2 plus 1/2 plus c. Negative 3 plus 1, that's negative 2. That's negative 1 over negative 1 plus c. So this will be negative 1 over t plus c. And that's the first derivative. So if we look at the first condition here, f prime here of 4 is 1. We're going to apply that condition. F prime of 4 is 1. This is a t value now. So wherever there's a t, we're going to put a 4 now. 4, 4, and the answer is going to be 1. So this means 1 equals negative 1/4 plus c, or c will be 1 plus 1/4. And if we do our arithmetic, c is 5/4. And let me do that a little better. So f prime of t It's negative 1 over t, where c is 5/4. Okay. So we need the function f, though. So remember, what this is saying is the derivative of f is negative 1 over t plus 5/4. So that means the function is found by taking the antiderivative or integrating what we see here. And do we make a mistake? Negative 3 halves plus 1 half is negative 2 halves. It's negative 1. We made a mistake. Oh, that coffee, ladies and gentlemen. I got to finish my coffee. This is wrong. Because I'm looking at this and going, you know what? This is a calculus 2 question now. Sorry, made a mistake. If I catch it, it's not a mistake. It's not a mistake if I catch it. Oh, my God. All right. Sorry about that, ladies. I was getting the answer already in my head. So I better get this. I got to get out of the Keurig. All right, I apologize. It's adding 1 by the power rule. So this will be a negative 1 half, negative 1 half plus c. Yikes. So that'll be negative 2 over really the square root of t plus c. Okay, so this is going to be my f prime of t now. All right. Yeah, it looks like we're good now. Okay. F prime of 4 is 1. So, and also at the same time, I'm looking at all the happy Thanksgiving wishes that are coming in via text. So the value of the function is going to be 1. So this would be 1 negative 2 over the square root of 4 plus c. Now this is more like it. 1 is negative 2 over 2 plus c, or 1 will be negative 1 plus c. Add 1 to both sides, and you get c is 2. Okay, c is 2. So that function here, that derivative of f prime of t becomes, where are you? You're right over here. Negative 2 over the square root of t plus 2. Yes. Okay, good now. Alrighty. Now we need the function again. So I'm going to just go over again that particular detail of what this actually means here. Looking at this as notation. So our function will be found by taking the antiderivative or the integral of what you guys see here. Oops. Plus 2, not c. Okay. And that's d2. Okay, power rule here. Now, let's make sure we do the right power, not give the answer. 2t plus c. 2 over 2. 2 over 2. Negative 2t now. Negative 1 half plus 1 plus 2 halves. That's 1 half over 1 half plus c, which would be negative 4 now square root of t plus c. Here's your function. Let's look at the condition now. The condition you guys have here is going to be f of 4 is 4. F of 4 is 4. Okay, so replace t with 4, replace t with 4, and your answer is 4. So this will be 4 equals negative 4. Square root of 4 plus c. Square root of 4 is 2. 4 is negative 4 times 2 plus c, or we say 4 will be negative 8 plus c, and that means c will be the number 12. So verify that, ladies and gentlemen. As you guys know, I'm not awake. I think it's 12. And that's going to be your final answer, though. Let's find it right here. This will be 12 right in here, right? Okay. So I'm going to write it here. F of t will be negative 4 square root of t plus 12. There we go. There's your function. There's your solution. Solution to the differential equation here. So, all right, we're on our way. Yep. Anyway, okay. Now let's go on. Let's finish number 10 here. And again, we have a second derivative here. So I'll go through that. We're going to have to get the first derivative, subject to the conditions, subject to that first condition. F prime of 0 is 2, and then subject to the last condition. So the variable's t here. So we're going to differentiate, and we're just going to use notation. This is the definition of the second derivative. It's t minus cosine of t. So to find f prime t, we have to integrate t minus cosine t with respect to the t variable. That's dt, which will be 1/2 t squared minus. All right, the antiderivative of cosine is sine. So here's that derivative. Now, let t be 0 here. So if t is 0, we can find c. They're saying this answer will be 2. So we have 2 equals negative 1/2 z squared, t squared, 0 squared, minus sine of 0 plus c. So this is easy. This means c is 2 now. This is 0. This is 0. C is 2. F of t, really f prime t, 1/2 t squared minus sine t plus 2. You're going to need a page. Okay. So we're going to now find f of t, again, by taking the antiderivative. Alrighty. So there it is. Okay, let's get antiderivatives here. All right, so f of t is going to be 1/2 t cubed over 3 minus the antiderivative of sine, is negative cosine. Okay, and that'll be plus 2t plus a c here. So let's do some arithmetic. That's 1/6 t cubed plus cosine t plus 2t plus c. What is the function? F of 0 is a negative 2. So f of 0 is negative 2. So we're going to plug in 0 here for t. And that answer should be negative 2. So we get negative 2 is this portion 0. This portion 0. Cosine of 0 is 1. So we get negative 2 is really 1 plus c, or c will be negative 3. So your answer here, your final answer. F of t, 1/6 t cubed plus cosine t plus 2t minus 3. There you go. There it is. Okay, I think we did 11 in class, which means we're going to try 13 or 12 here. All right. So we did 11. We're going to do 12, 13, and 14. And there you go. So, okay. So now this is another particle amount moving along the x-axis. Horizontal, you sort of motion, particle movement along a line is what I want to say. And they're saying you have a velocity of 6t squared minus t, and that's measured in meters per second. Find the particle's position function, st, assuming that s of t is 4 meters. That's a position at 2 seconds. So this starts off by notating that velocity, ladies and gentlemen. Let's get a pen. Velocity is the derivative of the position function. And they're saying that is actually going to be 6t squared minus t. In other words, s prime t is really 6t squared minus t, and they're asking for you to give them the position function. Find the particle's position function, st, subject to this condition. It's a differential equation because s of t is the antiderivative now of 6t squared minus t dt. So we get 6 t cubed over 3 minus t squared over 2 plus c. Your position function will be 2t cubed minus 1/2 t squared plus c. There you go. Keep in mind, s of 2 is 4. Okay. S of 2 is 4. So let's plug in. When t is 2, we know the position is 4. So we're finding the constant c here. 4 is 2. 2 cubed minus 1/2. 2 squared plus c. 2 cubed is 8. So it looks like that's going to be 16. 1/2 of 4 is 2. So 4 is going to be 14 plus c, or c will be 4 minus 14. C is negative 10, ladies and gentlemen. So there we go, negative 10. So this number here is negative 10. Could never really transition so well. It's very cumbersome. All right. S of t then, 2t cubed minus 1/2 t squared. C is negative 10. So you're looking at it right here. So here's a practical use of fundamental, straightforward use of finding, I should say, of integrating, in all honesty. Solving a differential equation, that's a first order equation. First order because of the fact that first derivative. Easy peasy, first order differential equation. Find simply the position function subject to your condition. There you go. All right. Okay. So we're going to look at question 13. We're going to read this one. Beginning at t is 0, they have an initial velocity of 4. Now, t is 0, your velocity is 4. What they're saying here is this is called initial velocity. V of 0 equals 4. Okay, that's what that means as we read this. Time is 0, velocity is 4. Particle is moving in a straight line again. Your acceleration that they gave, which happens to be, ladies and gentlemen, the second derivative of the position function. And they're saying now is 3 square root of t. And, acceleration is measured in units of meters per second squared. So this is what they mean here. And, of course, what that means is that you got the second derivative here being 3 square root of t now. Find the distance traveled after 25 seconds. So they want us to find, when they say, what's the distance traveled? Distance traveled after 25 seconds. We got to be careful with that. They're not saying what's the position. Time goes from 0 here, in this case, to 25. So they want the distance traveled after 25 seconds. We're going to have to be careful here. Okay? It's another assumption that they're going to make. Let's see how this goes. But, yeah, let's be careful about it. I'm just going to remark. Let's try to find the position function, okay? So, as you guys know, this is a second order. So, what this is, second order differential equation, we're going to get the position function. S prime t is 3t to the 1/2. So, we're going to integrate. S prime t will be the integral of 3t to the 1/2 dt, which is 3t to the 1/2 plus 1, 1/2 plus 1 plus c. All right, so it'll be 3/2. So we get 3t 3/2 over 3/2 plus c, which is really 3 2/3 t to the 3/2 plus c, which is 2t square root of t plus c, if you guys want to look at it that way. But you know what? Let's keep it as the 3/2, okay? Just notice that your 3's cancel. So 2t 3/2 plus c. This is that position function now. So you might even say, well, what is distance traveled? Well, ladies and gentlemen, we're going to have to apply here. This is s prime is 0, since that's velocity is 4, right? So we have to apply the condition to get our constant. S prime is 0 is 4, because that's what velocity is. It's the first derivative of the position function. So 4 is 2. You can say 0 to the 3/2 plus c. This portion is just 0, so c is 4 now. Excuse me. Okay. C is 4. S prime of t is going to be 2t to your 3/2 plus the constant of 4 now. Alrighty. Now you say, well, what's the deal with this? Yeah, let's double check something here. All right. So I just kind of want to, express something to you guys here. I want you to give you guys a note, because this is a very tricky kind of thing. Distance traveled is not really, it's not s of 25 minus s of 0. This will be the net sort of distance traveled, if you guys remember particle motion. Now, when I'm looking at this velocity function, I can tell you that where is velocity zero? It's never zero. This particle never stops, by the way. And it never stops. It never changes. Particle never stops. It never changes direction. So, never stops and it never changes direction. If you guys recall, you have to do sign analysis on that first derivative. So, looking at a critical value, that's t is, that is never zero. So I say your velocity is never zero. That means it never stops. If it's not stopping, it can't change direction. So when you try to find this distance traveled question, it's a very special question. But the devil's in the details. If you guys recall, particles can stop and change direction, and you can try to find this s of 25 minus s of 0 difference, but it's not necessarily going to be the distance traveled. It will in this case because of the fact that these problems are specially chosen. So that's something that people maybe don't realize. These problems are specially chosen. So it's going to be s of 25 minus s of 0 because the particle never stops and it never changes direction. Think about that. Sign analysis on the first derivative. It's never zero, right? So we can't change for positive or negative. That's going to be always positive. This particle is always moving to the right. So, okay, so now what does that even mean? Well, what that means is we're going to find the distance traveled by, yes, you're going to have to find this position function, which will be the integral of 2t 3/2 to the 3/2 power plus 4 dt, starting at 0, ending at 25. So this will give us what we're looking for, right? Because we're looking for eventually will be s of 25 minus s of 0 here. That will give us the distance traveled. Technically, it's the net distance traveled, but this particle never stops and never stops or changes direction. So, we start by trying to get that s of t function, which will ultimately be the antiderivative of that evaluated at those endpoints, right? So that's kind of what we're looking at, just so you guys know. So it's very similar to what we ended up with yesterday. So let's get that antiderivative, which would be 2t to the 3/2 plus 1, 3/2 plus 1 plus 4t. You can say, is that plus c? No, we could, but we're going to evaluate that from the starting point of t is 0, because time is always positive, to t is 25. So yes, this is, again, the whole idea would be that s of t, or not s of t, s of 25 minus f of 0. It's a specially chosen question, so that this works out this way. Alrighty. Whatever. Let's get the answer. T to the 5/2 over 5/2 plus 4t. T is 0. T is 25. T to the 2/5. T to the 5/2 plus 4t. We can just put 0 and 25. 4/5. T to the 5/2 plus 4t. 0 and 25. So now just plug in your values and do your arithmetic. 25 to the 5/2 power plus 4 times 25 minus 4/5 times 0 to the 5/2 power plus 4 times 0. So we need extra paper. Add a page. This portion is 0. Okay. So you get 4/5. Now, this is where students may remember, well, what is this? This here is really 25 to the 1/2 raised to the fifth power, which is 5 to the fifth power. So 5 to the fifth power here. 4 times 25 is 100, and then that's minus 0. So this is 4 times 5 to the fourth power times plus 100. Now, 5 to the fourth power here, I guess we could leave it that way, but I'm trying to look for my calculator. 25 times 25, okay, it's going to be, I believe, 625, right? Because we did a little bit of algebra there with 4. Algebra down here is what I'm saying. We did this. That's to the fourth power. So I believe that's 4 times 625. We could do the arithmetic. But let's see. 5. Yeah, 625. And then times 4 though is 2500. So let me do this here. This is 2500 plus 1, which means your final answer is 2600. So that's how far the particle has traveled. Now, this is a very specially chosen question again, because really this is net distance. Anyway, it's net distance. So we got to be careful. This is net, even though they say distance traveled. So after 25 seconds, it's meters per second. So, all right, there you go, ladies and gentlemen. It's really net distance, and it happens to be total distance. Net distance isn't always total distance, because it just depends on if the particle stops and changes direction. We worked on these in the beginning of the course when we did derivatives. Anyway, alrighty. So it's a specially chosen question. So net distance is the same as total distance traveled. All right. At what time t, a car traveling at 25 meters per second begin at a time t, and these kind of worded really weird some ways, you know. So the car starts at t is 0, traveling at 25 meters per second. This is a velocity, by the way. And you know it by the units. Velocity is 25 meters per second. And that's at t is 0, right? So they should just say, hey, car has initial velocity. Not at time t, a car is traveling. All right, via 0 is 25, which means s prime is 0 is 25. Saying the same thing. Begins to accelerate. Okay. And then your acceleration again is going to be -4 meters per second. So this acceleration is -4 meters per second. They're telling us this. So acceleration is constant. It's going in the negative direction, right? How many seconds does a car come to a stop? What? Car's coming to a stop. How many seconds? That's car stops on velocity of 0, which is really s prime. That's when the car stops. And then how far would a car have traveled from t is 0 until the time the car has stopped? All right, we need that t value. So we got a differential equation. So you might say acceleration is constant -4 here. Let's get the velocity function. It's integral of -4 dt, which is -4t plus rc. So here's the velocity function. What is c? Well, remember the initial velocity is 25 at 0. So if I plug in 0 here, velocity is 25. So 25 then is that 0 plus c, which means c is 25. So here's your velocity function. S prime of t is negative 4t plus 25. So there's velocity. Now remember, they need the time t where this velocity, the car stops, right? At what time does the car stop? Well, when your velocity is 0. The car stops when this equation is satisfied. So we're going to set that equal to 0. So what that means is, if s prime of t equals 0, that means negative 4t plus 25 is 0. Negative 4t is negative 25. T is negative 25 over negative 4. T is 25 over 4. This is the time where that car stops. So remember, the car is traveling in a direction, and in this case, it stops and may change direction. Okay? Now, what do they want to know? They want to know, after how many seconds does the car come to a stop? We already found that, 25 fourths. And so we found this first part. And how far will the car travel between t is 0 and when the time is stopped? 25 fourths for your t. So it's between 0 and, so the time, they're saying how far distance traveled between these two things. That, ladies and gentlemen, again, we need a position function. In other words, we got to solve a differential equation here. And, okay, let's add a page. Okay. And as you guys can see, again, it's going to be from 0 to 25 fourths again. So, okay. So that's going to be negative 4t squared over 2 plus 25t, evaluated from t is 0 to the 25 fourths of a second, which is negative 2t squared plus 25t, t is 0, 25 fourths. So negative 2, 25 fourths squared, 25 fourths, essentially minus 2 times 0 squared plus 25 times 0. You're looking at s of 25 fourths minus s of 0. So, ladies and gentlemen, that's negative 2 times, I guess, yeah, we'll do it this way. Negative 2 times 25 squared over 4 squared plus 25 squared over 4. Now, doing some arithmetic. Final answer is going to be, really, you got the following. 4 times 25 squared over 4 squared minus 2 times 25 squared over 4 squared, which is going to be 2 times 25 squared over 4 squared. So 2 times 25 squared divided by 4 squared, ladies and gentlemen, will give you 78.125 numerically. Anyway. I mean, we could do it this way. We can just say, you know what? 25 squared is 625. So 2 times 625 is 1250 divided by 16. We'll keep it as a fraction. There you go. That's fine. We know arithmetic, I hope. All right. Very similar to what we've been doing. Very similar. Now, the last one's kind of nice, too. It's kind of a cute question. A 9 100-kilogram rocket is released from space. As it burns fuel, the rocket's mass decreases and its acceleration increases. Okay, makes some sense. Let v of m be the velocity as a function of mass. Okay, find the velocity. So here's the question. Find the velocity. I highlight it. Find the velocity when mass is 729. So v of 729 is what they're asking for. Find the velocity when mass is 729. So now you have the following here, right? dv dm is negative 50 m to the negative 1/2. And they have a condition to this differential equation. Okay, so we really need the velocity function. They gave us the derivative of the velocity function right in here. So what is v? Negative 50 m to the negative 1/2 dm. So let's get this. M to the negative 1/2 plus 1/2 plus c, negative 50. Here we go. M to the 1/2 divided by 1/2 plus c, which is negative 100 m to the 1/2. So, okay, here's the velocity function. It's negative 1/2 or negative 100 square root of m, square root of the mass, plus c. So we have to apply the initial condition to get the constant c. So they're saying when mass is 900, the velocity is 0. So yeah, because it has a full tank of gas, I guess. So it's not even moving. Okay. 0 velocity when it has all the fuel. Now, square root of 900, right, is the square root of 9 times, that's going to be 3 times 30. So we say 0 is negative 100 times 30 plus c. Or we say 0 is negative 3,000 plus c. So your c is 3,000. C is 3,000. So here's your velocity function. Okay? And in terms of mass, so v of m, negative 100, square root of m plus 3,000. There we go. Now you go, well, what was the original question? They want to know what's the velocity when the mass is 729. 729. So some fuel left. That's all. So your some of the fuel's gone. V of 729, negative 100, square root of 729 plus 3,000. So I'm going to punch this in a calculator here. Negative 100, you guys can't see that. Sorry, square root 729 plus 3,000. That's 300. Wow. Okay, now it's 300. So what's the story? What are the units? Meters per second. So it's meters per second. Okay, so here's the original, I should say, here's the function. Here's the answer to what they're looking for, that when the mass is 729 kilograms, 300 miles per second is the velocity. So, ladies and gentlemen, happy Thanksgiving. I can now relax and then get ready to do some cooking. Okay, so I hope you guys enjoyed this video. I'll send it to you. I finished these answers for you guys. Take care, stay safe, have a wonderful Thanksgiving. Review these things, and I'll see you guys on Monday.